All right, in this video, we're going to look at a problem where a boat is crossing a river, and we're given the velocity of the boat and the velocity of the river. And we're asked for the magnitude and direction of the boat's velocity with respect to the land. So that you'll see this type of problem often in early on in a physics class when you're trying to get the idea of how vectors work in physics. So let's go ahead and read through the question and figure out how to begin the problem. So we have a boat that sets out to cross a river at a speed of 5 meters per second directed north. The river has an eastward current moving at 4 meters per second. We want to know the magnitude and direction of the boat's velocity with respect to the land, and also how long it takes to cross the river if we know that the river is 32 meters wide. So here's our river, and we have our boat here. It is setting out north. So we'll say this is north, and we have south, west, and east. So we have a velocity vector headed north toward the other side of the river. We will call this velocity the velocity of the boat with respect to the river. So with respect to the river, the boat only has a northward or vertical velocity, and it has a magnitude of 5 meters per second. And then the river itself is moving with respect to the land. So if you're on the land, it looks like the river is moving eastward. So we have an eastward vector with a magnitude of 4 meters per second. So we'll call this the velocity of the river with respect to the land. So the first subscript here is what's moving, and the second one is what it's moving with respect to. If you're standing on the land, the river looks like it's moving at this velocity. So this is 4 meters per second. And so what we want to know is basically the hypotenuse of this triangle here. So this is the velocity of the boat with respect to the land, so VBL. So we just have a right triangle here, and we know the two sides of the triangle, VBR and VRL. And we want to find the hypotenuse. So we're just going to use the Pythagorean theorem, right? So VBL equals the square root of the two sides squared and added together. So the horizontal component is VRL, the velocity of the river with respect to the land, and that's squared plus the velocity of the boat with respect to the river. This is our vertical component, squared. So let's go ahead and plug in the values that we have. And this is going to give us the magnitude of this velocity vector of the boat with respect to the land. So this is 4 meters per second squared plus 5 meters per second squared. So this is just going to give us 16 plus 25, and we take the square root of that. And that is going to give us 6.4 meters per second. So this is the magnitude of our velocity vector. And now we want to find the direction. So that's this angle here. This would technically be the angle that you would turn your head if you were standing from the departure spot of the boat to see where it ends up on the other side, right? So if you're looking at its final destination over here, this is the angle you'd be looking at. So again, we're just working with a right triangle, so we have to do some trigonometry. We know both of the sides of this triangle, and we're trying to find this angle. So what we can do is use tangent of theta. So tangent of theta is equal to the opposite side of the triangle, or the side that is opposite of the angle, over the adjacent side. So in our case, that's going to be VRL over VBR. Now, we want to solve for the angle, so we have to use the inverse tangent. So inverse tangent of VRL over VBR. So that is the inverse tangent of 4 meters per second over 5 meters per second. And this is going to give us an angle of 39 degrees. So this is the magnitude and direction of our velocity vector. Now, in some cases, in some problems, you may want to find this other angle here. So the angle from the horizontal axis. And that's, of course, just going to be 90 minus 39 degrees. And that would just be 51 degrees, if the question that you have happens to ask for that angle instead. Now we want to find how long it takes to cross this river. So we know that the magnitude of velocity or speed is equal to the distance over the time. So instead we want to solve for the time. So we're just rearranging this distance over velocity. Now, this part can get a little bit confusing when you have several different velocities, right? So what you have to do is make sure that the distance that you're referring to corresponds to the velocity of that direction. So what I mean is, in our case, we know that the width of the river is our distance. So what we'll need to do is use the velocity that's only in the vertical direction. So it's in the same direction as the change in position here. So in our case, our time is equal to 32 meters divided by VBR. So that's 5 meters per second. And this is going to give us 6.4 seconds. So you should get the same answer if you were to use the horizontal distance that the boat has moved with the horizontal component of velocity. Or if you happen to know the actual distance that the boat traveled with respect to land. So this distance here, we'll say D, or D2. If you were to know that distance, you would divide that by 6.4 meters per second. However, we're given the width of the river, so we're just going with that vertical component of velocity. You should get the same time no matter what, because so we're moving this vertical distance in the same amount of time that we're moving that horizontal distance. So the time would be the same no matter what one you use. Just make sure it's in the same direction. So anyway, our time, given that we know the width of the river, is 6.4 seconds. So hopefully that was helpful and help you understand how these kinds of problems work. So let me know in the comments if there's anything else that you would like to see, any other types of physics problems. And thanks for watching.